Okay, so let's officially get going here. Keshe Plasma Reactor Group. We've met Tuesday nights for the last 3 years or so. We being the group has, not necessarily the people in the group now, because it's all changed over that time. But I'm wondering what questions people might have out there or in here as such. And let's sort of work with that. Let's work with what is urgent or necessity right now for on people's minds.
I want to ask one question, Rick. You know when we do the unit, I was told in one of the meeting to plug our McGrath unit in one room furthest in the house and then move it closer to the meter.
Right.
But now that I read the McGrath plan that come out, they told you to plug it in and don't plug it out at all, unless it's faulty. Which one is correct?
Right. Well, maybe they're both Rick? Correct. Pardon me. Go ahead.
If I might, John here. Hi, Michael. I was the one that brought up the idea of starting with one circuit at the far end of the house and working your way towards the breaker box. That made the most sense to me. And the idea about not plugging it in or not unplugging it and plugging it back in, I view it sort of like a balloon. When you plug the system in, it starts to inflate this balloon and your plasmatic pressure builds. When it gets to a certain point, it's nice and stable and it sits there and everything works really good. When you unplug it, you deflate that balloon. And when you plug it back in again, it takes a little while for that balloon to re-inflate again. So when you move the device from one room to another or from one circuit to another, there's going to be a slight delay, probably an hour, maybe 2 hours. I don't know. I haven't tested it. Where it's really not going to be doing anything but actually recreating that plasmatic pressure within that system. So depending upon how your house is wired, some of the houses in Canada are very complex. They have many circuits and they're not even anywhere nearly remotely connected to one another except at the breaker box. So to expedite the nano coating of your house, I suggested start at the longest run you've got, the farthest away. If you've got a circuit in your garage or down in the basement on the other side of the house from the breaker box, or upstairs on the other side of the house from the breaker box, start there, do the longest section first, and then move your system to the next, excuse me, to the next circuit. And that way you can get a nice even nano coating throughout your house. But you are going to have that short period of time where you have to reinflate that plasmatic bubble. I don't know if that's the right way to think of it, but that's kind of the way I visualize it. Does that make sense, Michael?
That makes sense. All right, go ahead.
Yeah. Yeah, you can do it from there, Rick.
Yeah, go ahead. I got a couple of questions about hooking this the energy unit up the house.
Yeah, the question that came up that brought that to my mind was whether to hook it directly into the fuse box or the breaker box, or if you start at one end and work your way to the breaker box. And the reason that came up was a typical water heater is a resistive load at 6,000 watts, which is way beyond the capacity of this thing right off the bat. So if you put it in your breaker box, if you put it in the heart of your house right off the bat, you're going to be over, you're voiding the warranty right immediately. Uh, yeah, something's going to give out. Something's going to give out. So that was the question that came up in the discussion, and the first thing that came to my mind is, why not do each circuit individually? Start with the longest circuit, work it so that the nano coating gets to your box, and then switch the circuit to the next one till it gets to the box. And once you've covered all of the circuits, then when you put it in the box, because that was the end goal of the questioner's plan, then your house is done. You don't have to worry about the big loads in your house already, air conditioner or the water heater. It shouldn't. It seems to depend on the load you put on it. One of the things Vivek noticed when he had his load on his system, he had just a light 3-watt LED lamp, and it didn't seem to do anything. And then he's talking to me, and I says, "Well, let's kick it up. Let's put your fan on there." So we put I think it's 140 watts now on it, and it didn't get hot. Nothing happened, but it seems, just the feeling that I get from the way he's describing it and my connection to the field, it seems that it's happier with a little bit more load. And I think that's what Moran brought out the first time he discussed this, was to put like a 200 or 250 watt load on this thing. Don't be super, super gentle with it. And then I noticed a couple of times a bunch of people are saying, well, no, he said plug it in, leave it for 3 days, don't put anything on it, then put a really light load on it, then add a little bit, a little bit, a little bit. That seems to be counterproductive to me for some reason. Yeah. But we're trying to get that nano coating to travel through the system. Go ahead. Go ahead.
Microphone was off on live stream, unfortunately.
Uh-oh.
Okay, sorry about that. We're getting all my elusive thoughts there, or supposed to be lucid. Elusive is more like it. Elusive thoughts. They're more elusive than lucid at this point. In any case, just talking about nano coating and whether one should move around to different circuits in the house, or my philosophy is put it in the heart of my house and put it in a prominent position where I almost trip over it all the time, where I have to pay attention to it, where it becomes part of my daily routine to interact with this machine that's sitting in it's not a machine, actually. It's more like an organism that would be sitting in probably the living room area, possibly bedroom, depending.
Yeah, one thing I'm curious about, Vivek, well, since you've put the larger load on your system, have you noticed a different feeling in your room?
Actually, there was an interesting sensation. The very first time I plugged in the unit, without plugging any load onto it, there was this smell that permeated the room, and my eyes started burning a little bit. But then that went away. Now, today when I re-plugged in the unit and I plugged in the load, the smell came back, and it's still lingering. but there's no burning of the eye. That's what I'm observing here right now.
But
Maybe.
you don't have a feeling. It doesn't feel like it's relaxed or it's excited, or you don't feel different in the room.
Not really, no, because I'm actually feeling a little bit ill, so I'm not as sensitive today as I would normally be.
Okay.
Yeah.
Was that Vince coming in? Wanted to say something? Sounded like him.
I was thinking maybe could be a residual chemical or something from the GANTs on the outside, just burning off at first.
Could be.
Yeah, it was one thing that I wanted Vivek to check when I suggested to put the load up, was to monitor the temperatures, temperature of the motor, temperature of the wiring under the system, and see what's going to get warm. And he mentioned nothing really changed. So I'm wondering if that odor is sort of the field itself that's being inflated, as I mentioned earlier.
Yep, it's possible.
Mike, is the odor was it like an electrical type smell or ozone smell, or can you identify that a little bit?
No, it is actually, I would say it's closer to a fragrant kind of smell. If let's say you have a jaw stick or something like that, that's the kind of smell that I'm smelling. It's not unpleasant. It can be a little bit overwhelming at times, but other than that, it's a little bit fragrant.
It wouldn't be the plastic smelling, would it, or something else?
No, plastic has a very different smell.
Okay, well that's interesting. Manifesting
And
floral essences.
Yeah, I keep an ashtray in my room because I smoke, and the smell is definitely very different from that. It's not a cigarette smell.
Well, that's interesting. I wonder if anybody else has any experience with a floral type smell, let's say, from their unit. That would be something if it created plasmatic fields that had a pleasant odor like that. That would
fragrant.
Yeah.
Well, we've got a number of
be.
people now who are very energy sensitive, who are starting their systems up. Susan is one of them.
Mm-hmm.
And over the next several days, week or so, it would be very, very interesting to query them about the feeling that they're getting in their room when they're next to this reactor. What the feeling is different, and when they make a change, if that feeling changes, because we know this plasma is alive. It's the consciousness. It's the same thing that makes us conscious.
Mm-hmm.
So I really don't see any stretch to think that there's going to be an emotional output that we're going to be able to pick up from this if we do it right or if we do it wrong. If we overload it, we're going to get really tired. Things won't feel right. It just won't feel right.
Mm-hmm.
But if you do it and the machine or the device is happy and the plasma is happy, you're going to walk in and you're just going to enjoy being there. You're going to want to be there. It's the same sort of thing as you walk into a room and just you feel happy for some reason. You don't know why.
Yeah.
People around are talking, but you want to be there. Or you walk into a room and you do not want to be there. Go ahead.
A positive attraction.
Exactly. And,
yeah,
and I think that's going to be our biggest yardstick.
Right. Like some people, when they walk into a room, tend to generate that energy or that field, you might say, that people will be instantly attracted to them and just want to be part of that energy and part of that. Or contrarily, they might be repelled by it because it's too intense for them, and they would consider a person like that with a strong field to be too, they might say they're too egotistical or something like that, but it may not be that.
Yeah.
That may not be the case necessarily. It may be just a strong presence, just a strong presence.
I
By the
I just
way,
did something very interesting because we were talking about the smell. Sorry to interrupt. I went and put my nose right up against my stacker unit. I can't smell the smell there. But when the moment I step back a little bit, I can smell it. It's permeating my room, but I cannot smell it directly against
Right
the
on.
stacker
That's
unit.
very interesting. Yes, I think that's
Okay, so
significant.
it's definitely a field phenomenon. It's not an
Right,
actual odor that's emanating from the device.
right. And it
Can,
would be
can
similar
I ask,
to, go ahead.
can I ask what GANTs you used for your nano coating? What metals and what combination you used, and what combination you used for the center ping pong ball?
Okay, for the ganses used, they're all the same for the ping pong ball, for the coils and the capacitors. It is a mix of pure zinc, iron, and copper GaNs. Because I used the electrical method, at that time I did not know about the aquarium pump being required, and that is what it produced. There is a little bit of carbon dioxide, copper oxide, and CH3 in there as well, but the majority of it is the pure GaNs of zinc, copper, and iron.
Okay, interesting.
Interesting.
So I was wondering, anybody else here has felt any difference in their environment with their machine running? How about you, Michael? Like, can you just say anything about that initially with your unit? Your unit has crystals and a pyramid on it, and you've plugged it in and so on. You must have noticed something with it or not.
Well, I plug it into my furnace room in my house upstairs, and I sleep in there. I haven't noticed anything, but I just have a comfortable sleep and enjoy being there with it.
Mm-hmm.
So that's why to take it to my personal bedroom. That's why I asked the question, because my plan was to move it to my bedroom now, so I can monitor it in my own space. So I will be doing that tonight. I will move it to my room. So if it take 1 or 2 more hours to float back up, that is fine with me. And then I will.
Well, that'll be a good test. You can report back what if any differences might have occurred from that moving process.
Right, and then I've got to add more load to it because I had an LED light. It doesn't give a lot of wattage, so I'm going to upload a fan to it today. For
Okay.
3 days. See how it goes.
Really good.
Yeah, thank you.
by the way, I tried to share a couple of times, but I
Oh,
was also in a hurry to tell something. It's Chandra here from Hungary. I know that feeling of different smell, a different odor when you enter a room where you have plasma. My maggraph system is under construction, but I have a couple of units around with like CO2 kits and other GANS kits, and quite large, such as 3 liters each. And usually in the morning when I enter, just I can feel if there is a change or not. So I cannot correctly describe that feeling, but it's absolutely different, and it's very special one. It's not something subtle. When you enter, you feel it.
Yeah, the feeling aspect of this is going to be a very important measuring stick that we need to be aware of.
Yes.
Yeah, agreed.
And meanwhile, Rick, it was a question, I think, from Gambi. He said, Keshe mentioned metering the coils after the first nanocode. Could you clarify? So I'd like to clarify that for everybody, because this is utmost important to success or insuccess when you make the coating. It's not after the coating, it's a part of the coating. using ohm meter and to do this applying a small voltage at the ends of the wires while the wires are wet and just you took them out of caustic. So if you wouldn't mind 5 minutes for that, I could show that live how to do it.
Yeah.
That'd be
Is
great,
that also
Shandor,
how
if
you
you can do that.
determine direction of flow in the wire?
Exactly. By applying a voltage to the wet wire while you just took it out of caustic and ready to put it into the box for conditioning, it just determines the direction of the flow and the direction of structuring of the network of the nano coating. So it's formed a copper oxide. So there are copper atoms, oxygen atoms arranged like in the shape of a sieve with gaps and holes in them. And if you don't do this, you just get a bunch of random material. But if you do this, you will have a graphene-like, I don't say graphene, I mean carbon, but graphene-like structure, just like you have a sieve on the surface of something. If you don't do this step, you will have a dark black color thing, but it will not work in the plasma means as you expect. So this is very important. There are so many tutorials which people start typing, but they miss these little but very important things.
Yes. So also you can determine not only the flow, but whether your coil needs to be flipped over or not, or which way is going to be up for each coil.
Well, Sean, you're not determining where it is at that moment. You're creating the conditions for it to be what you want at that moment.
Okay, I'd suggest to show the process how to do it, and later we can develop it of where and how and how to do the fine tuning. Just I want to show the process, and later you have to put your own thinking how to make it to be in a proper way, in a good direction.
Okay,
yes,
do you want to do that?
What plus, what minus. So you determine the direction of the flow. So
do you want to show that now, Shandor, you mean?
Yeah.
Great, thank you.
So here I have an empty box with a sieve on the bottom. There is some caustic left from the previous treatment. Just I didn't want to wash it because it's quite a good condition. Basically, you just put at the bottom of a box chicken mesh, and you can put some wires, and you put some sticks or some glass to hang things there. And here in the other box, I'm opening it carefully. Condensed water is dripping. Here it is a batch which is since 36 hours in caustic. So I used to recommend when you do the nano coating, when you do the caustic method, you put some caustic on the bottom of the container. You put the chicken mesh, then you put your copper pass, and then you pour hot water, boiling hot water on it. And then you cover it and leave it for 1-2 days. So this is 1.5 days here. I will need this meter, and always use gloves for your safety, because caustic makes very bad things. So I just put the coating, some old used copper plates as well. And I'm just using this opportunity for recoating them too. So with these wires, I have the advantage that I can easily hang things. You see, when I'm making these plates, I used to make some hooks from the same material, which makes it very easy to hang it without the need to do all kind of making holes or using clips or other things. So I want to have this here. So these are not needed for the process, just they are in the same batch of coating. So now let's fish out this carefully. So this is a small coil. And what I want these ends to be visible, because there are several coils inside. Each one has an exit. It has an entry. Okay, this is an exit. This is an entry.
What are the outside diameters of your coils?
Yeah.
Well, the outside diameters aren't really
an
that
entry.
critical.
The other is an exit. So already I make here a way how to find them each entry and exit ones. Just some I cut shorter. Okay. Now next one. Let's look at it. This is the exit, and from the thick one, from the thicker coil, and this is the entry. Entry here, exit here. So in this case, it will be easy to not mess up with them, so to not mix them up accidentally. I read the tips of the wires to be handy. Okay. 1, 2. And the inner coil, let me see it. Obviously, this comes out from the center. This is the exit, and the other is the entry. So I put all entries there or exits here. So this will make it easy to not miss the points. Okay, next also. Sorting by exits and entries. You know how you put the circuit, you have entry and exit points. Okay, this is an exit. This is an exit here. This is an entry here. This is an exit here.
Sandor, I don't know if you're going to need to, but I'd be clipping some of that wire off. You look like you got way too much.
No, it's not wearing off. It's broke. You're talking about my gloves?
No. I'm talking about the extra wire you have in your coil. The length of the wire you have in your coils. That's you got.
Okay, let's talk out the time about the length of the wires. Just, I want to go further with this step, and I have 3 more coils to put here. Fortunately, I ran out of the spare gloves. Okay. This is an entry. This is an exit. Entry. And exit. Okay. This is an entry. And this is an exit again. Okay. And there are 2 more. Okay. This is an exit. This is an entry. So before to do the nano coating, always soften your wires. The end of the wires, the tips which you have to bend later to make the connection. I feel the difference. So this is not too good to do it after the nano coating, but before. Oh, create a small coil for another purpose, just in the same batch. Okay, this will be something different. Okay, and this is the last piece.
Hey, Sanders, are you using the same wire that you started with, the real hard stuff?
Sorry, I cannot listen now. Okay. Let me finish with the next coil. While working with caustic, it's good to focus, not to do any mistake, to drop it in the wrong place, and I don't want to mix the coils as well. So we'll discuss later. So this is the entry, and which is the exit. I want to proper. Yes, this is the exit. I will explain on the whiteboard. Just a second. These are two exits, and those are two entries. And thank you for asking, because almost I made a mistake with the other coil. I have to change the previous coil direction.
I do have some clarity. I was under the impression that the wire itself had a direction of flow if you tested the ends of it even before you coiled it.
Well, you will find
this is what I missed the direction.
You will find there's a little bit of polarity in there, but when you apply the voltage from your voltmeter, you're actually setting the direction, not reading it.
Copy that.
Yeah, I did put this in opposite way. This is the exit here. Actually, okay. This is also an exit. This is an entry. This is entry, and this is entry too. So I have to hang the entry on there and the exit here. Okay. Now give me 1 minute to remove the gloves and wash my hands. Okay. So take off the gloves, safety.
So I have a rod that's probably about a ½ inch in diameter that I'm going to be wrapping on my coils with. Is that too large, or should I go with a smaller rod?
If you want to waste more copper, you make this coils thicker. If you want to use less copper, you go smaller. You can go smaller, it doesn't matter.
Yeah. What's most important is the relationship between your inner and your outer coils. If you're using a ½ inch coil or ½ inch rod for your outer coils, and your wire is 14 gauge or 0.065 inches, then your inner coil needs to be a ½ inch minus 0.13 plus a little bit to give a little tiny bit of space. You're looking at 20, maybe 30 thousandths of an inch, 0.02, or sorry, 0.02 or 0.03 inches space between the coils. You want them fairly close.
Yes, I'd like to follow all other nice subjects that we are making a video recording of this. And I'd like to not need to cut too many parts of it, because it should be a demonstrational video too, this section, okay? So let's finish with these coils, and let's continue then with how to make the coils and other many things, because there are 1,000 little things. Just let's go in order if possible. Is it okay? No? Okay.
Yeah, go ahead.
So what I wanted to do here, is just to show in flow how to do the process. So yesterday I made a small video about how to put the coils into caustic. So today I shown how we take out the coils of caustic and we put into another box for conditioning. And I used here 2 copper wires on which I'm hanging these. And one is for the entries, the other for the exits. For the rest of the coils, which the wires are not enough long, at least I directed them, the entries toward there and the exits toward this part. So now the next important step is to give the direction of the flow. So this is a multimeter, and we set it up to 2 kilo ohms for measuring resistances. Just I'm taking off these protective caps. So you see, it shows 0, 0, 0. This means short circuit, 0 resistance. Okay. We have a plus, we have a minus, and this gives out a small voltage. It's a 9-volt battery inside. Those who have no multimeter can just use a battery with 2 wires, but to know which is positive, which is negative. It's not important the value which we are measuring. It's important very soon after we took out from caustic these coils or the plates, we have to give the direction of the flow of the creating of the structure of an ordered nicely arrange the nano coating. If you don't do that, it will be a bunch of atoms, molecules mixed together. So now I decided this is the entry, this is the exit, and I put the coils in the same way. I will explain later how to determine which is entry and exit, which is very simple. So just put the desired entry and exit, the voltmeter or the ohmmeter for about 10 seconds. Okay, let's go to next. So this is entry of the inner coil, this is exit of the inner coil. Just give some voltage on it.
Sandor,
Okay.
can I ask you
So
why you're using the polarity you're using?
I didn't understand the question.
You have the negative on the exit and the positive on the entry. Is there a
Yes,
specific
yes. I decide to give a flow of energy.
Well,
I will explain that later after we go through this process. It's about 10 seconds per each coil. There are 12 coils, so it's a 2 minutes process at all. After that, I will explain which is entry, which is exit, and how is about the flows, okay? Just not forget some pairs of it.
I
So I
understand.
start to make an order, to not forget which I did, which I didn't do. So I do first the inner coils and the outer coils. We'll give those 10 seconds, okay? Let's go to the next. Okay, let's go to the next. Entry and exit. Best to do it at the end of the coil. Okay, next. Entry point, exit point. Next one. This is I just verify whether I missed the direction or not. Yes, this is the entry. This is the longer entry. And this is the exit. About 5–10 seconds. Entry and exit. Just I have to chase the end of the coil because this is a rather long one. Not that one, it's its neighbor. So that's why it's good to put 2 wires, because I can hang them to keep them stretched to be easy to recognize which is which. So this is entry, and this long one is the exit. Okay. Okay. And go to next. Yes.
Hi, I'm Stefano.
Buongiorno.
Buongiorno. I lose a piece of video because I was out.
No problem. There will be a recording. You will watch it later.
Okay.
And I will explain it again. Just have to finish with this little process.
Okay. Okay.
So
Perfect.
always find entry and exit and give the direction, plus or minus. This will determine you the direction of flow of growing the nano-layers.
The black on the minus.
There are 40 seconds more only.
Okay.
Or less, 20 seconds only. Okay. Okay, and display it also.
Okay.
What is the meter on the? What is the readings on the meter while you're doing that?
Readings doesn't matter. Do not matter. It's a 0. It's good because in resistance 0, it means the current passes through. And I have here another thing. Oh, another piece here.
So if you get a reading, then that's not good.
Yeah.
Okay.
So on meter, the readings are just reverse. I just had here a health coil. So I'm making that too.
Yeah, the reading is not necessarily, if you get a reading, it's not necessarily not good.
This is no reading on a meter. And it is reading when I connect them together. It means it's conducing the electricity. If here it shows some figure, it means it's a higher resistance. So we did this. We put the top and we leave it. I used to do this at least 1 week, but better 2 weeks. Okay, now let me take a breath and show about the direction, because there are so many questions. I have to move the camera in the right way. Okay. Let's find the right position. I hope it's seen. Okay. Let's delete the previous notes. So, and I'd like to repeat this again.
Uh-oh, I lost you.
He'll be back.
There you go. Yep.
Did his microphone come unplugged?
No, his mic is part of the camera.
Oh. Okay.
Can you hear my voice now? Maybe it's different quality. I changed to another microphone. Yeah, this is the backup options. I have the microphone all-in-one in the camera, and I was trying to set up the camera just a second to set the focus to not automatic. Come on, open please. I have a software here which doesn't want to pop up its window. It's there, but it doesn't want the truth. Okay, I have to click twice. Adjust the light.
Good morning, everyone. This is Sylvester.
Okay.
Hi, Sylvester.
Is it okay now? Focus for the backboard.
Yeah, you're fine, Sandor. Just keep going.
Sorry for sometimes my USB. I have a Dell computer. It's a great one, but the USB sockets are not very good, so a bit loose connection, not very tight. Știu că nu se aude bine, domnule Florin Crețulescu, măcar mă auziți cumva. I know you don't hear me well, but at least you can hear me because I have a technical issue with my camera's connector. And I use a second microphone, which is the microphone which is inside. But at least you can hear me. I will talk louder, okay? So now I was talking about when you make these coils and you do the nano coating, of course, it will become more interesting because they will be in such a shape, but basically it's like that. So everyone, you have an entry and an exit point, which is decided by the circuit, how you put them together. And you apply here an ohmmeter, which gives out a little voltage, or you can use simply here a simple battery with 2 wires, but this is an essential step. If you don't do it during nano process, you just make something black and the plasma will not flow on it. So you decide where is the entry and an exit, and I recommend when you cut the wire, because the wire it comes through technological process in the same direction. Also, it has a direction. So always keep the entry and exit in the same direction of the manufacturing of the wire. Okay, when you do the nano coating, you apply this caustic, high temperature, and some atoms will be released. But now, if you don't do anything to make an order there, what will be created there? It will be just a bunch of unorganized atoms, and your nanostructure will look something like in this way if you look at the microscope. To make it a smooth, conductive, superconductive layer, this is your copper,
you apply here a small voltage between 2 points while it is wet. So it must be wet with the caustic solution. So you apply here the positive and the negative, and you give here a flow, a direction of the flow as you wish. So now how you know, what does it do? It makes this bunch of atoms to get more organized. So you have such a copper atoms. You have oxygen atoms, and to create a nice structure, a nice uniform structure, then you will have to give this electric current to it to get somehow in an organized way. Where you give a current, they try to align each other. Where you don't give current, they'll make connections at random. And you will have no superconductive properties. So is the thing. So how these connections between the atoms are done? What you need to have a uniform layer. So that's why you must apply the small voltage for 5-10 seconds on the surface of the copper to give the direction of the flow. In case of the coils, you do this once. In case if you make the nanoplates, the nano-coated plates for gas collection, there you apply it at random at different positions. Once you apply in this direction, you give a direction of the flow. Later, after 4 or 5 hours, you apply from another direction, from here to here. You make another layer with a different direction. And you repeat this in different instances. Every 4 or 5 times a day, you apply voltage in different random points, which is good to create a gradient. Because in this way, every layer or a batch of layers of the nanostructures will get different directions. So we'll have a higher spectrum for collecting the CO2, for instance. That's where you need the uniform coating. You apply the voltage once, but don't forget to use it, to apply it at least once. Now, how to find the entry and the exit point of the coil? You have to remember. You have to remember about the way of connecting the coils together. So now I draw the I draw with blue the gravitational coils, those with thinner diameter, and with red the longer and the thicker coils. So you have a system of 2 coils. So now when you connect them together, you go first inside, and when you look from up, you see, here is an entry, which you mark it with minus on the scan, on the surface. This is entry. Then the end of coil goes again through itself. When it goes out, it goes into the next, which is exterior to it, which again goes through itself. Here you have a connection, and here this is end of it. And this end, normally it will be bent somewhere here. And it will be bent over the wire, which goes to the next coil, which for simplicity, I put it into the next drawing to be easier to see. So always you enter in the middle and you go to exterior. For the gravitational coils, you go with directional flows in clockwise direction, here twice, once with the coil, once with the termination of it. And you go anti-clockwise in the case of the gravitation when you look from up. So this connection point gets connected here to this inner coil. So here you have, let's say, the point A. The point A gets connected to here. So we understand that here it comes the connection to it. Okay, here also this will be continued. Then you have here the exit. This is the direction, how you direct the flow from here, and again it goes to the outer thicker coil. Again it goes in counterclockwise direction, and here you have an exit. So now these for the circuitry are marked with plus and minus. But when we give the direction of the flow, we just apply plus and minus on the other end. So I want to push, so I put plus here and go through it and give a direction to it. So every time I decide to put one pole of the voltmeter on entry and the other on exit. So here the entry point, let me mark with blue, with green. So this is the entry. This is the exit. This is the entry. The other is the exit. This is the entry. This is the exit, and this is the entry too. Okay, is that clear? It seems now we have no problems with my microphone, but with the other microphone. So many people have so many questions. Now I'm ready for the questions. So sorry for.
It's clear, Sandor. It's clear, Sandor. But what you just described, what's on your board, is exactly the opposite of what you did on your actual coils.
Why do you think so?
You reverse biased your actual coils. You put the negative on the exit.
Yes,
rather than
yes.
Why would you have
sign plus or minus? I decided to give the direction with negative on the entry and positive on the exit.
I understand that, and the electron flow is going to go from negative to positive. Yet when
what
you did it,
electron flow? Sorry, explain that for the AC current.
AC current doesn't have a polarity, only DC
okay,
does.
we are doing now magnet system for AC.
Then you shouldn't be biasing it with AC or with DC. I don't. This is
electron
the question.
Flow, how does it go?
This is the question I have. How did you determine the biasing of your coils? Whether the positive lead of your meter goes to the entry or the exit? What is the factors that determine that?
It's not important on which you put the positive and the negative. Just do it in the same way for all. You know, when the atoms get arranged, what you have is, in fact, there is a copper. Oh, sorry, let's make it with red to be more copper-like. Okay, so this is a copper. This is a copper, 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 and copper, and copper, and copper, and copper. And let's put the oxygen as well. Oxygen, 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 and oxygen, and oxygen. And let's make the connections. Okay. So if you have this pattern, on the scale of the atoms, tell me what makes difference if the current flows this direction or that direction?
then the entire exercise is moot, because all you have to do is put current in it in some fashion. The entry and exit don't really matter.
Yeah. So anyway, you decide how you make it. You do it as you wish. I don't say you must put the plus here and the minus there. You decide about it, but do that uniformly for all.
Well, I'm just trying to understand your reasoning
And why you put
behind.
uniformly? Because if you want to repeat in the same way. Okay. But what's
Okay.
more important to put in the right position, not in the middle of the coil, not here and here, but the end and at the end.
Okay, thank you.
So what you want? This is your random. Nano coating which starts created something like this. And when you put the current, you stretch it. You understand? So instead of being something randomly arranged, you stretch it with giving electricity on it, so it comes straight, like when you stretch a sheet on your bed. If that the picture gives you better remembering and understanding.
Okay, so first you wind your coils in the directions you want, and then you set the nano coating on the outside for that direction, correct?
Yes.
Good. Thank you very much.
You're welcome. Okay, you have the screen, you have the microphone, you have the camera. This was important, which I wanted to tell to you, to share with you. Thank you for opportunity for I could record this. So we have a little video about this technological phase, which is important. And if you miss it, maybe you will have no power output at all. This is quite an important step, even though it's a very little one. Such an important step, for instance, after you made your coil, you assemble them, you trim at the proper length. You don't trim them after you did another coating, you trim before. Next important thing is to bend its end, to make a small loop there. So bend the tip of your coil. This is the wire. This is very important. To not let the energy flow out, but to turn itself back to itself. And then next important thing, use such a gas torch to soften the ends of the wires. So those which you have to twist one over the other, soften them before you do the nano coating. And when you do the nano coating, you put them in caustic. You have already the edges at the right length. You have the length, the tips are all trimmed. You have all the wires softened. You put them in caustic. You leave them 24, 48 hours. And when you take it to the second phase, to this drying phase, then you apply a voltage to the entry and exit of each wire, to determine the direction of the flow to be not at random, so not in this way, but to be all in the same direction. For the nano layers to grow uniformly and not somewhere in such a random way, if I can.
So you apply the electricity, or you set the direction each time you nano coat?
Yeah. I mean the direction of alignment of the atoms. And when I say direction, I now don't see from A to B or from B to A, but to be from A to B and not from another direction. So what I mean, I set a direction this way and not this way. You understand?
Right.
They not this way, but in that way, along the wire and not in a random thing.
Very good.
So
thank you.
If you don't do that, you will get such a thing that you will have such all kind of bunch of structures like this. But if you apply the voltage correctly, instead of that, you will have such a uniform structures everywhere. Not a bunch of mixed atoms, but you have that graphene-like structure which is needed for energy to flow uniformly.
we should be clear that it should be a low voltage as well, because any kind of higher voltage will tend to fluff up the layers rather than make them compact.
Low current. It's not the voltage, so what, but the low current, milliamperes, microamperes. So that's why the ohmmeter is quite good, because the instrument has quite a high internal resistance when you put it at least 2 kilo ohm. Don't put it on ohms or on. So you have a scale with different values. We have here one from 0 to 200 ohms. That gives a pretty high current. Go higher to not to 2000 to 20 kilo ohms. Sorry, not to at least about 220 kilo ohms. The instrument adds some resistance internally.
Sandor, I have a question. Sandor, I have a question.
Yes.
Mr. Keshe mentioned yesterday that for those people who did not do this, they need to strip the nano coating and redo it. I'm sure a lot of people have this question also. How to strip the nano coating so that they can redo it?
You put them, thank you for the question. You put them into your box with a little bit more caustic than usually, and you add a big chunk of aluminum, but a big one. Not foil, not something thin, but a solid piece of aluminum. You put the hot water, you put the top on it, and in a ventilated place, because hydrogen is formed, so you don't want to reach dangerous conditions. And that the aluminum will keep it boiling, keeping the high temperature, and then the pieces will fall off.
So that means the box must be left open, not covered up.
No, closed. If it's open, it cools down too quickly. You need it closed.
Okay.
So this is I found, and later what you collect, that black thing on the bottom, you don't throw it. That's a nano copper. It's a nano copper oxide, which you can use later for other things in your energy devices.
Okay, thank you, Sandor.
Okay, it's quite tricky to get good results. So you have to find your proportions, ratios. So I did this in a 40 liters container, and they are quite different conditions in a 4 liters container. Smaller is better to not waste too much energy, water, and the chemicals.
Okay, thank you, Sandor.
You're welcome. So next, please.
You're still muted, Rick.
Playing while I'm muted. Okay. Thanks, Shandor. I was just saying thank you for that, and now you've got a video that you can use as well. So that's good.
Welcome. So I don't want to occupy all the playground.
Right, so we have to see what people like to discuss here, what other things are on the mind besides the ins and outs of the nano and so on.
One of the things I brought up just before the recording was the little tidbit that was released yesterday during the Chinese workshop about how to use the reactor unit as your source for a real style, or at least the beginnings of a real style Star Trek kind of replicator, where you split the output into 4 pieces and you modulate each output variable in strength, apply that to a nano coating wall of its container filled with salt water, and you get your materials inside that container. Very interesting concept, and it's something that we'll have to look at as we go.
Someone's sharing something here?
Yeah, Jamie had a question. There was something that came up about not using a meter on your nano coating, and I wasn't sure what he was talking about, but I mentioned to him that he should at least bring it up just so that we can clarify this.
Yeah, if I could play a couple minutes of part of the blueprint leak. I think it's addressed there. I was trying to figure out how to get it up there. I think I got it figured out, if that's all right.
Yeah. If you want the sound,
sure, James.
If you want the sound, we're not seeing the video, but if you want the sound to play on it, you have to click the little box when you do the screen share that says play computer audio. Yeah, we're not
hearing the audio.
Not getting the audio because you have to click the little box that says play computer audio when you start the screen sharing. So you have to stop it and then restart it.
In the meanwhile, let me just share in the chat, which is not seen on live stream, just on the Zoom chat. Mihai Sabo told that it is another method to get rid of the old nano coating by using electrogalvanic process or electrolysis. So you put in a caustic solution, in a used caustic solution in the oil, and you apply current with minus on the piece where you.
Okay, when I nano coat these coils, so let's see here. This is the in,
yeah,
and this is the out.
No, this is the out. This is the in, this is the out.
Okay, but I have this too.
Yeah, but that's the in of the magnetical, and that's the out of the magnetical.
Okay, so this part is the in of both.
Yeah.
And this part is the out of both.
Yeah.
But the direction changed because in this coil I move clockwise.
That's what, yes.
And this coil I move counterclockwise.
Yeah, that's the field movement, not yours.
That's the field.
That's the field. It's two different things.
Okay, so when I coat my coil, in my understanding is I have to apply a voltage, millivolts, to give direction.
You don't need to. You
So
just put in a caustic and you can do it.
Okay, because in my understanding, well, what I'm doing at the moment is applying. Just because in my voltmeter, multimeter, the electrons move from the minus to the plus, I'm applying here the minus and here the plus.
Yeah.
And here the minus. Here the plus.
No, your gas coating or your your electric coating.
No, I'm coating with a caustic, but when I make my coil dry,
no,
I apply a millivolts.
You carry the same proposition, still minus, still plus.
Same.
The same.
Doesn't matter if in one coil the direction. Okay.
No. So you nano coat it the same way, and you place it in the same way. When you're going to get your coil, is the flow which counts, not the matter.
Yes.
So if you change it, you create an opposition, and then your system doesn't work. You have losses.
Wow.
You understand?
Okay.
So this in a way goes, if you do it that way, this goes this way, this goes that way, you create a obstruction.
So that suggests to me that the gravitational goes essentially, that may be reversed this way, but essentially the gravitational goes from negative to positive, the magnetical goes from positive to negative. So as long as you do them both the same, you're maintaining the flow directions of each individual energy form. for lack of a better term. I think I understand it a little better now. And everybody's muted. The whole board is muted.
I'm
Rick,
still
if you
here.
want to make... Oh, Rick is still there. Rick isn't, though. Armin's on. Hey, Armin, how you doing, buddy?
Good morning, everybody.
Good morning.
Hello, Armin.
I just got in, so I don't know what you're talking about.
We were discussing applying a small current to the coils for the reactor device, and an apparent, I don't say it's an actual, but an apparent discrepancy in the biasing of your meter to the coils, and it, for some reason, it just didn't seem to gel. But we just watched a video from Mr. Keshe, and I think it made a lot more sense now.
Okay.
And Rick is still muted. Well, I don't want to drive the bus.
So, as far as the meter on the coils thing goes, it's the jury's out a little bit on that in terms of whether it's necessary for the power units or not. But on the other hand, we've had other information back in the good old days when we first heard about the nano materials, which was, as I recall, the idea was to not to put power into the nano coating, but to actually remove the charge from the nano coating to allow it to be tighter formations from layer to layer. But that's another.
For the repeated process, in case you apply the tips of your wires next time, second, third, fourth, in case you make such a plate for CO2 kit, in that case, first time you apply a little voltage with your ohmmeter, and the second, third, fourth, fifth time you apply at your voltmeter, you discharge the charges. You don't apply again an external current. You just use the internal voltage, which will create the current. But here is Armin online, so he is our
expert
member in technology, and he has the highest knowledge in making prototypes, and the most expert in nano coating. So maybe he can share his say with us. So what's his opinion and what's his view about these things? So I think he had built the first prototype, which have been developed later as the final commercial product. So he has to know about that. So Armin, what's your advice about this applying the ohmmeter on the coils during the wet stage of the process?
If you do the voltmeter, you have to remember where you put your plus and where you put your minus. Then you have to follow the same way. Because when you apply it, you already give a direction to the plasma coil.
Thank you. So that's why I used in this little setup. I don't know if you have been here. So I just start my video again.
Yes.
I just put two wires. I have here two longitudinal wires on left and right of the box, and it gives me an orientation which I use for exit and so on. But it's important that it has some wires are going into that direction, some wires this direction, and that gives me a sense. And you see, as soon as I put them, I took out from the caustic and I did this. Already it started becoming black.
Okay.
And I put this.
Why you're not doing deep caustic?
Sorry.
You have to do this deep caustic first. Then after that, when you do your connection, then you can do the vapor too.
Yeah. Just I had here the box with caustic where these coils were put first time 36 hours or 37 hours ago. So 1.5 day they were in caustic, completely immersed, and just I did this applying the multimeter after I put them in a wet condition.
If you put that, you know, how long you put 7-8 hours and they not black?
In the caustic?
No, after you
no,
put
they were here. I have liquid caustic in the small box.
Okay.
I put them 1 day before last night.
But
it was
still,
just a bad.
after 1 day, then your copper is not, you know, pure copper.
It's an electric copper. It's a commercial copper wire. It's not a high grade Hitachi patented oxygen-free like used for.
No, not oxygen-free. You know, it's a very hard to find oxygen-free. If you find oxygen-free, that's the best. But you know, it's there are mixtures which you know there are maybe 98%. You know, you can find in the market. That's the best, because if I do the caustic, the second day it's black, totally black.
Yeah, so we take 36 hours in caustic, and it depends also on concentration.
No, I leave it 1 day. After 1 day, I just, you know, leave it for dry another day. But then after, let's say, 48 hours, it's totally black.
I think you buy your copper from USA, and that's a copper from Chile mainly, and that's a better copper. And what we have here is an Indonesian copper, which comes to Europe.
Oh my God!
It comes from China and Indonesia.
No, I buy the copper. It's I specifically look at it's 99%, 0.5. You know, it's a very less mixture in it. So that's the best. You know, it's right away after 48 hours we have perfectly nano-coated material.
Yes.
Armin, he took the coils out of a submerged bath. They weren't exposed to the air until he hung them up in the larger container.
Yeah, but he hung it up already a day, you know.
No. He pressed on them minutes.
Oh, a few minutes.
They are still wet. They are still wet. They don't dry in 1 hour.
Yeah, but you know, if you buy a 98%, 0.7, you know, they sell always the copper like that. So if you buy that copper, it's the best. And it's a very.
I know my experience, my first experience in nano-coating in my life in 2014. Maybe I can find the pictures of it. I used the copper foil from a Motorola battery, from the old cell phone battery from a Motorola brand, and those became so beautifully black white in caustic. So that was a much better grade of copper.
Yeah.
So I stopped my video and I try to find that photo. 3 minutes, and I will share that to see the difference.
You know, you can find it in eBay. If I can send you the link, even it's from America, they ship all over the world.
Yes, I know, but I have to wait 30 days to get it, and I wanted to start here to do the first demonstration unit. So I rush. I had a night or time to rush 2 hours to the next shop and to buy whichever copper coil is available here, or copper wire.
Just to clarify, guys, Armin and Sandor, just to clarify for the folks that are fairly new here, because I do see a number of new names. Every single time I've done nano coating, when they're in the bath, when they're submerged in the caustic, I don't see any black at all until they're exposed to the air.
That's
and
correct.
Then they
That's
start
oxidization process.
That's right. And it's and the real magic happens when they're in the caustic vapor, not the bath itself.
No, first because it's a coil, correct? So to do the deep caustic first one, after you connect your stackers, you know, inside and outside the coils, then you can put one more time in a vapor that maybe you didn't miss a part. So this is how I do. I don't know. I do 2 times. One, then do all the connections. Then when I do all the connections, then I do the vapor.
Yeah, I typically do one submerged bath, just basically to clean it and prep the surface, and then 2 vapor coatings, and my nano coatings come out gorgeous.
Yeah,
And
you
we're
can.
now using the extended heat time in a crock pot, so they stay hot for 12 to 14 hours. And the coating that we just pulled out today is absolutely fabulous.
Yeah.
I'm sharing my screen. So these were copper foils from a used Motorola cell phone battery.
Yeah, it's a very thin. That's why you can right away nano coat those.
It's very thin and it's a special oxygen-free copper. It's a process
Yeah,
like
oxygen-free copper is the best. All my reactors is oxygen-free copper.
Yeah.
Okay.
So here
Yeah, I just wanted to clarify that for the new folks, because it was a little confusing even for me, and I've been doing this for a while.
So are there any metals that you want to stay away from in your nano coating?
Any metals, meaning?
Any metals, like you don't want to put aluminum, or you don't want to use cadmium or something like that.
Well, caustic and aluminum do not get along. Caustic and glass don't get along. So yeah, there are a few there that you probably don't want to have in the system.
So stick to the zinc, the copper, and iron and steel.
I don't know anyone who's nano-coated iron iron and steel are the same thing. The only difference is the carbon content. I've nano-coated zinc by accident. I think we're using copper because it's the easiest and it's the most versatile. Whether there's uses for the other metals, I don't know at this time. I don't think the lab has investigated that. Have they, Armin?
No, I've done several, actually, well,
aluminum
zinc,
plates.
Even aluminum, I done nano coated, but you leave in a caustic, not less than 10, 15 minutes, and leave it dry. So,
is there a specific purpose for the other metals?
Every metal you can do nano coating. It depends what you use.
Well,
when I was
is there a purpose for, say, specifically for aluminum? Is there a specific purpose for that? Is that a certain field? Well, I understand it's a different field condition, obviously, but
you answered your question. It's a different field condition.
Look up aluminum oxide. You'll find thousands of uses for it.
Yeah, in my trade, we use aluminum oxide as an abrasive. So
right.
I'm trying to figure out where would be the application for that. Some sort, just a starting point, someplace that I can point my thinking toward.
Well, for example, if it was titanium oxide or dioxide, which is used on donuts to make them white, then you can actually take the stuff from donuts, the titanium dioxide, and make a solar panel out of it. You can actually take donuts and make solar panels out of them that work.
Okay, so from my understanding, if I was to substitute my nano copper for nano aluminum, I would need to adjust the catalyst metal, which in copper's instance would be zinc, for carbon dioxide GaNs, for some other metal that would equate to the same field strength. Is that correct?
What would you want to be doing with it again to get some kind of different kind of GaNs, you mean?
About nano coating.
Pardon me, sorry, there's two voices there.
I said, we're talking about GaNs or we're talking about nano coating wires?
Well,
or nano coating plates.
I'm looking at what would be the point of substituting a nano copper for, say, a nano aluminum. Would it be if you want CO2 GaNs, you don't have access to zinc, so you need some other metal, so you use the aluminum and some other metal to get the field strength of carbon to get your nano copper or nano carbon dioxide?
I think you get a different material.
Different material, it's a different ingredients.
I was imagining when I was listening to Dr. Keshe talk that we would like to put in the middle ping pong ball as many different metals in the GANs as possible. Is that not true? To substitute like the Earth, or to substitute as many metals as in the Earth.
Actually, many metals you can glue it, paste it, on your coils. But in the middle, I will use copper, CH3, and CO2. This is your connection.
Yeah, because it needs to be connected to the body. Otherwise, you're going to wind up with a field that you don't want. There was a fellow who was going to do it with mercury. He was going to make mercury GANs and use that because it's a very heavy metal. It's going to be a very strong field. But what's the output of that field? Is it going to be an insanity field? I mean,
no, it's a strength of your plasma. You have to under the mixture of the GANs or heavy metals. It's a strength of your plasma.
Having more elements, yeah.
Microphone. People have talked about salt water having all of the elements that are in the blood and in the body and so on and so forth, and how it's, the perfect combination, and why not make GANs of that? Well, it's not a perfect combination. Try drinking salt water and see how long you live on it. You won't live very long at all.
No, it's not that. It's almost. They're talking about almost.
I know, that's what I mean. Yeah. So you're taking out something that's already so concentrated that we can't drink it and live on it, and concentrating it even more, and then putting it in the middle of your plasmatic device that's going to be emitting through your home. Don't know.
Did you ever make Ormus, Rick?
I haven't yet, no.
I did several times, and it's like CO2. It's white, puffy, very puffy, and you can collect, and even you can dry it.
Mm-hmm. Yeah.
Yeah. That in seawater we know that all the metals are floating in there. So when you put the caustic process, you create a nano particles, not GANs actually.
Oh,
okay. Use the caustic.
Alexander here, please allow us to use the presence of Armen for getting more knowledge. So Armen, when you make this MAGRAPH system coils and you apply GANs over the nano-coated coils, how you do? You put a GANs mixture, or you put them in a certain order? First you brush some kind of GANs, you dry it, then second you apply another layer, or how is the proper process?
I use when I collect GANs, I prepared everything, but I left not finished because I had very little time. So, but I have GANs, let's say lithium GANs, and I have neodymium magnet GANs, silver GANs, lead. You can do GANs from every material that you ever think.
Yeah, we also do such a mixture of GANs, and we have CO2 GANs, CH3 GANs, and copper GANs. So how you
then calculate whatever GANs you collect, and then minus 25%, then you have strength of your plasma.
Okay, so how you do the application of the GANs on the top of the coils? Are you applying the layers or a mixture?
No, mixture.
So you already mix all together and let them...
All the GANs together, put little bit caustic, sugar.
Yeah.
So for stickiness, and it's perfect.
Yeah, sugar has been used for China ink, for instance, or for the traditional ink. Substance which helps to stick together. You know what? If you touch a salt water, your hands don't become sticky. But if you touch a Coke or a sweet coffee which has sugar, your fingers get sticky. So sugar is good for stickiness. So we will not forget it. We know this thing about, and a few drops of caustic as far as Mr. Keshe advised.
Yeah, but I understand one thing. You can make a GANs in a not in a salt water, but you can mix it with the sugar. Copper GANs, I have one container, which is a sugar water container.
Great.
So it's
no
perfect
salt at all.
GANs too. Huh?
No salt at all. Okay.
Yeah, but it's and it's you can consider CH3. It's a sugar too. So when you have a sugar already, let's say in a copper GANs, so I use that one. But still, I put a little bit sugar.
Great. And if every GANs is made with salt, absolutely we must rinse. We must wash them.
I do three, maybe 4 times. Yeah, 4 times distilled water.
Yeah, that is needed to prevent copper to be attacked, the nano coating to not be attacked by the remaining salt.
Yes.
Thank you very much.
You're welcome.
So in conclusion, we make different ganses. We wash them out of salt. We apply 4 or 5 times more liquid on, not liquid, distilled water or demineralized water on the top. Let settle, and we take away the excess water. We repeat that 3 more times, in total 4 times. Then we remove the traces of the salt, and then we evaporate it to make it thicker. And then we put in a tray. We apply. We put the coils which are nano coated inside, and with the brush we brush thoroughly, or with a soft brush, not with a hard brush.
Yeah, it's like a thick stew, you know.
Yeah. And before to do that, we add a few drops of caustic into it to heal the nano coating.
You know when you do your nano coating, you know, keep that caustic.
Yes, so we use the caustic which we used for nano coating previously. So we
yes.
Put 2 drops of that, and also we add some sugar to make it sticky.
Yes. And when you use when you nano coat, you always keep the the caustic, a little bit of the caustic. I always add on. I have a bottle, so every time I use, I a little bit put that caustic in. So every time you nano coat, just keep a little bit of your caustic solution. That's all.
I'm keeping all. I have the empty bottles from the demineralized water, the heavy ones.
Yeah, and you know, guys, when you do your nano coating, and after nano coating, you can see the GANs. It's collected in the bottom of your container.
Yeah.
I collect that GANs.
Yeah, very
wash
good.
them always. You know, I have maybe a big jar of it. So all nano coating, what I do, I always let the caustic settle, and you see the GANs. It's formatting under the container.
I wanted to point here for safety, so I am going to share my video, so please watch this video. I have distilled water or demineralized water bottles which are empty, and I'm using some of them and repurposing them. Never put the caustic in such a PET bottle. It's the transparent bottle, because the caustic will burn it, and you will have leaks of caustic. So these are not good to store caustic. But these, which are made of HDPE, high density polyethylene with enough thick walls, these are suitable to hold the caustic into. So these you can use for keeping caustic, but when you put caustic into it, don't forget, it's very important always to put such a mark on it, to not confuse it, and to put your safety marks, there, and you say it's oxide and potassium hydroxide, whatever you use, to know later what you put stored into it.
You have to be drunk to be confused.
To avoid confusion, what you put here, because some bottles I use for salt water, for instance. Some others I use for other kind of byproducts, like they use caustic. And if I have this time on it, I never confuse it accidentally to touch it with hands or something, to do some very nasty thing. So caustic makes very bad burns. So if you want to if you have a strong spirit, a strong soul that you are able to watch such a medical photos, then Google for caustic burns, and I think after 5 seconds you don't want to see them anymore. But if you see it once, you never want to touch with bare hands caustic or to drop it on the floor, because even if you drop it and it dries later, it can make serious burns. So don't play easily with caustic. Keep safety first.
Thank you.
Okay.
I found yesterday it makes a great glass cleaner. I had some basement windows I couldn't get this film off of, so I used some concentrated distilled water and caustic and razor bladed it, and windows are so clean I can't believe it.
Just a tip, you don't have to throw away your used caustic. It can be repurposed for so many things. For instance, if you want to remove old oil paint from old furniture, caustic is the best to remove the old oil paint. But also you can use it for cold nano coating process. So it's not something you throw it out.
I have a suggestion for coating the coils with GAN. In my case, what I did is I made a thick stew and I used a syringe, a large syringe, so I could actually inject the GAN into the coils itself. And even applying it onto the top of the coils, it came out very, very nicely. It coated very cleanly.
But if you have like a stew, you know, it goes inside too. You just dip it in.
Yeah, that's right. I used a syringe to inject it in just to be on the safe side, just to be sure. And it went in very nicely.
Yeah, that syringe idea works good. I use that idea too. It works great.
Okay, I'm going to have to wrap things up fairly soon here, but what other questions or concepts?
What time teaching starts today?
The teaching will start at another hour.
I have a question.
The online teaching, that is. Yeah, okay, go ahead.
Okay, so I went looking for caustic at Home Depot here, and couldn't find any pure caustic in a bottle that said caustic. So I had them look up in the computer what they had in the store that had it, and all that we could find was this stuff called Crystal Heat.
Crystal
drain
Heat
opener.
Okay.
Yeah, you don't want to play with that stuff. Sean, have you got a Home Hardware in your area?
Yeah, at Home Depot or Ace Hardware or Lowe's.
Well, there's specifically the branch Home Hardware. They carry a 6-pound bag or a bottle of lye, because caustic is lye, and it's about $6.
Okay, I'll look. There's some other places here that are similar to that, I believe, so I'll check that out. So I will not.
eBay, the best.
Yeah, Home Hardware carries it. They have it on the shelf.
Just another tip, now there's a fashion for ladies to make their own soap. So if you search in your Google or Yahoo search, Bing search, whatever you want for soap making in your area, you will find forums where they post and they buy the materials. So actually, I had hard time to find a chemical shop here in Budapest, in the capital of Hungary, to find good caustic, and the only chemical shop I knew is too far from my home, and I was very lucky to enter accidentally to buy some essential oils and in a small shop, and they have a big supply of items for soap making, and they had even potassium hydroxide, not only sodium hydroxide, and cheaper than in other places, and it's just 200 meters from my home.
There you go.
Okay,
Yeah, another place.
Another option,
another place people can get it is where I found mine originally was at a radiator repair place, and they soak the radiators in caustic to remove some of the solder and guck and so on, to make it clean for repairing and to clean them out inside.
Yeah, I was going to mention that. Automotive repair, anybody? Get it as a drain cleaner, but the heat that you're talking about, it
Ask that question.
You might be able to find Red Devil.
Red Devil Lie. I know about Red Devil Lie. I couldn't find it.
Ormus.
Chemistry lab hours. So,
Yep,
I got
same
you.
here.
please use eBay, Amazon, and other sources to order, and it will be delivered. No problem. No problem.
I bought 12 pounds for $12 plus shipping. Not bad.
Here.
And it's food grade.
Thank you.
Okay, let's Rick to take a 1 hour break to prepare for the broadcasting, the teaching for the students. It's only 58 minutes left, and it will be a long day or a long night for Rick.
Yeah, Rick, hello everybody. I just want to share something and maybe you can expand or share ideas with me. What I did was my McGrath unit, I loaded a star formation. Hello?
I saw that today. I saw that formation, and I also saw the comments, a couple comments about that.
Yeah. The star formation is doing good for me. It helped me with my breathing. Everything become light and I can walk with speed now. So it helps me, the star formation. My thinking is that it's like if at any one time the McGrath can supply off grid, so it become an ancient technology. You understand? Yeah, so that is like wishful thinking. But my question is, I'm using an adapter to run my computer fan. Is that advisable?
There was something from the workshops where they mentioned that any of the adapters, the wall warts or the bricks, the voltage power supplies for small or low voltage devices all failed. So I haven't tested it, but I'm a little reluctant to be putting any of those type of devices into the system at this time.
So okay, I'll maybe find one. I find one without the adapter, direct connection. That'll be better.
if you've got, I don't know where you're at, whether your voltage is 110 or 220, but if you can find a device with a native voltage that doesn't require an adapter of any sort, that would be better to condition your system with.
Okay, I understand. I'll get one without the adapter then. Thank you.
Can you use a converter? Can you use like a DC to AC converter, and will that change it?
I was wondering that myself because I live in a motorhome, and pretty much everything in here is DC except for my computer and my coffee maker. So if I can use a true sine wave inverter off of the 12-volt batteries to run my plasma system, that would be awesome. I don't know if that'll work though. Yeah.
Or
Yeah,
use
but
the
according to
same
Mr. Keshe,
setup?
according to Mr. Keshe, we will have an add-on unit for the devices very shortly where we don't need to plug them into the wall anymore, and that will save a lot of headaches.
That will be a great thing
Well,
indeed.
how about the automotive application coil setup directly into a 12-volt to 110 converter?
It's possible. That's one of the sort of things I'm looking at because I'm also looking at systems for handicap scooters as well.
They're almost always
And,
not a sine wave, though. And Mr. Keshe was explaining that it should be a sine wave, not a like a chopped wave or a square wave or triangle wave and that kind of thing.
Yeah, that's one of the things that I'm looking at because I don't know how they're going to react with the controllers on those devices. They're all using brushless. Well, the ones I'm working with are all brushless motors, so they should interface perfectly. Whether or not the speed control is going to work, I don't know yet.
I would run your inverter through an isolation transformer, and it'll clean it up.
Which should blow up if the plasma, what we're told about the plasma, works properly.
Yeah, it could be tricky.
You don't want transformers in your system.
Yeah, transformers will be tricky. We need plasma transformers, which is a whole different ball game. Anyway, I have to wrap things up here for now because I have to take a break. But sorry, I'll try to get started earlier next week so we have more time here so we can converse more.
Thank you for the invite, Rick.
Did you get a new toque, Rick?
No, this is an old toque actually, but I do have a new toque in the back 40. I've got another hat I'm going to wear.
Getting cold up there?
It's starting to
Freezing
get.
here.
It's almost down to freezing. Yeah. It might get to freezing here this year. Where I'm at, it seldom freezes. Actually, we didn't even get any snow last year.
I'll be damned. Where are you at?
I'm in the warmest part of Canada, in Vancouver Island, on the west coast.
All right. Good night, everybody.
Alrighty, thank you very much, everyone, and thanks, a big special thanks to Shandor, who gave a good teaching with his coils and whatnot there, and got a bit of food for thought.
Thank you.
Thank you too, Michael. Looking forward to seeing more of your devices. I'm sure you will once they get bedded in there, so to speak, in your bedroom. And
okay, from Sama, thank you everybody. Thank you, Rick.
Okay, take care.
Thank you, everyone. Thank you, Rick.
Thank you, everybody.
Yeah, it's
from Italy, Sylvester. Thank you.
It's a good family of people we have here, and it's great to get together. Let's I'll try to arrange a little more organization for next week. I've got some things I do want to show, so I've just been really busy with some other stuff until the end of the month here, and then I'll be rocketing into other things. That'll be really fun, I think. All right, that's it for now, and see you next week, or see you in the online teaching, or somewhere else in the universe. Okay, bye for now.